Welcome to Hitex and to today's webinar with Eva Rio from Tuxera. My name is Wolfgang Fuller and I will give you a short introduction about Hitex before the webinar starts. Hitex was established in 1976 as an embedded development company and has achieved rapid growth by developing and providing microcontroller development tools. Today, Hitex as a proven expert is also in great demand as a service provider for training and consulting, test services, development and production services. Hitex supports all phases of your project from the idea to the finished system. No safety without security. The role of cybersecurity, CRA, and functional safety in connected embedded systems. You will learn about this and Tuxera's approach today from Eva Rio, Portfolio Manager in the Embedded Business Unit at Tuxera. So I'll hand over to Eva. Eva, please.
Hello, everybody. Thank you for joining. My name is Eva Rio. Thank you for the introduction, Wolfgang. I've been working at Tuxera for about 11 years or so. I'm portfolio manager in the embedded business unit. I'm responsible for the product and market mix of our embedded solutions and the go-to-market as well. And today in this webinar, I'm gonna talk about the role of cybersecurity and functional safety in the new way of designing embedded systems. Okay, let's get started. Today, first of all, I will say a few words on how cybersecurity and functional safety relate to each other. Then we will look at the CRA. Hitex has had already several webinars on what CRA means for embedded devices, but I will still reiterate a few of the key points on CRA and what it means for manufacturers and software providers. And then we look at functional safety, how standards like ISO 26262, for example, in automotive, and then in other industries are shaping the embedded industries. And to finalize, we will look at how to design embedded systems so that security and safety work together and that you can ship them to market. What type of steps can organizations take? This slide is foundation for the entire webinar. It's the heart of the whole discussion. It represents the idea that safety and security are no longer separate worlds. Eventually, functional safety and cybersecurity both share the ultimate goal, which is to keep people, data, and the assets safe, but they approach it from different angles. So when we talk about functional safety, we are talking about minimizing risk from unintentional failures, like for example, if a sensor malfunctions or if there is software bug. So in functional safety, we are assuming that failures will happen by some sort of accident, like a hardware fault or a bug, and we build redundancy and other type of control mechanisms to prevent harm occurring from that situation. As you know, you can never truly prevent every failure from happening, but you can always recover to a safe state, and that's what functional safety aims to achieve. Cybersecurity, on the other hand, is protecting against intentional manipulation. So with security, we are assuming that failures can be caused intentionally by some sort of attacker trying to manipulate the system. The main problem these days is that devices are, as you know, more and more connected, and once a device is a part of a network, cyber attack can cause the same harm as a fault in practice. In today connected devices like cars, industrial controllers, smart meters, these two domains are overlapping. System can be functional safe, but can lose the safety aspect if it's vulnerable to an attack. So that's one of the reasons why security and safety are these days closely linked to each other. This is the reason why we say that no system can be considered safe unless it's been secured as well. And security shouldn't be treated as an add-on anymore. We will look at that in the next slides as well. But it needs to be part of the same development life cycle, from requirement definition to development and verification, all the way to updates and to the device being deployed in the field. At Tuxera, we consider the union of these two aspects, security and functional safety, as system integrity, so the intersection between safety and security. because integrity will depend on both aspects. So safety handling the faults and security preventing the tampering. So together, when we make them work together, we ensure that the system behaves predictably and safely, even in the face of faults or attacks. Most of you might have seen real-world examples of cyber incidents leading to physical consequences, like cars being disabled remotely, power grids disrupted, or medical devices being hacked. And as I mentioned before, cybersecurity and security incidents can lead directly to safety failures. So when safety critical systems are exposed to a network, data breach can become a safety hazard. And this is why standards or regulations like CRA, Cyber Resilience Act, play an important role. They are setting the baseline for secure by design development, meaning that the products can just be safe, they might also be secure. In the case of the CRA, this is requiring the manufacturers to think about cybersecurity from day one. As we said before, you have to consider security practices in your whole development process, as well as vulnerability management and on all the ongoing updates for a product. One thing to remember about CRA is that it doesn't apply to every sector directly. Other mission critical industries might have its own regulations, like automotive has 21434, and UNESER 155, and then industrial has other standards, and so does medical. But for most embedded products, the CRA is giving a starting point that helps you align safety and security practices. It's meant to help organizations raise their cybersecurity maturity level, and in turn, it will enhance the functional safety as well. So a product that's designed from the ground up securely will be less likely to experience failures that can compromise the safety or go against the certification requirements. One of the key takeaways with the introduction of the CRA, if that wasn't clear before for the industry, is that security is really no longer optional. And it cannot, or it should not be bolted on after you have built the whole device and after testing. It needs to be considered from the very beginning. And it's becoming a prerequisite for safety. The CRA applies to any product that contains digital elements. And yeah, as you know already, it's one of the biggest regulatory changes that will hit the embedded market. The goal of the CRA is designed to build trust between manufacturers and the consumers by ensuring that the products are secure by design and that there is a process in place that will help handle vulnerabilities, deliver patches, and overall maintain security through the product life cycle. Yeah, but as I was saying, the CRA applies to all products with digital elements, which means that if the product or your product is connected to a network or processes data or can be updated, it will fall under the CRA scope, unless you are part of more stringent type of industry like automotive or medical. In that case, other standards may apply, but the baseline is the same. In practice, the CRA requires manufacturers to identify and mitigate risks associated with the digital component of the product, monitor and handle vulnerabilities. So you need to have a vulnerability disclosure and a patching process that can be available for your customers to see. Provide security updates, of course, during a defined support period, and everything needs to be documented before the product can be sold in the EU. So cybersecurity becomes more of a legal compliance requirement, not just a best practice. The CRA expects to be fully applied by 2027, with the first compliance steps starting as early as last year already, when the regulation entered the EU law. And it doesn't require compliance yet, but from now on, the countdown just begins. And companies need to start preparing, evaluating what type of security practices they have in place, mapping their product to these practices, and identifying which parts will fall under the CRA scope. to say once again, like if you are designing, manufacturing, or selling products with digital elements in the EU, this will affect you. By 2026, and this is part of the CRA text, manufacturers should already have in place mechanisms to collect, analyze, and report vulnerabilities to the EU authorities. So even before full enforcement of CRA, companies will be required to show that they can manage vulnerabilities responsibly and transparently. And then in December 2027, products entering the EU markets must comply with CRA. So if the product doesn't meet these requirements, can't be sold or CE marked in the EU. There's been discussions whether this deadline will be pushed slightly for future years, but nothing concrete yet, as far as we know. Failing to comply to CRA will have some penalties up to 2.5 of the global annual revenue of a company, but beyond the fines, it's about market access, like being able to sell in the EU, and overall customer trust. Once the CRA is in place, the idea is to keep the process, of course, ongoing through continuous updates and revisions. So the CRA will be evolving as technology and threats also evolve, and we will likely see revisions of the current CRA documentation to align with new standards and maybe additional guidance for AI or IoT products. So it's not necessarily just a one-time event, but you can think of it as a process in time. But long story short, the companies that begin preparing now will be the ones ready to ship safely and securely by the end of 2027. In addition of a technical issue or a legal requirement, is also a business imperative from that point of view. One thing to mention is that the CRA doesn't replace other standards. I said before some examples from automotive and medical and aerospace sectors too. They also have their own safety and cybersecurity framework. So it's good to think of the CRA as part of this bigger ecosystem of security standards and regulations that have been developed over the last decades across these safety critical industries. Again, the CRA becomes a baseline for products that have digital elements and how to handle the security, but then mission critical industries continue to handle their domain specific details. The CRA from that point of view is not sector specific, but it's rather a horizontal regulation that applies to the devices, reinforcing consistent secure by design principles and practices. And these are some examples and headlines across industries of major fines, lawsuits, loss of customer trust. These are threats or ransomware attacks, examples that have happened mostly on high-level type of systems, not necessarily embedded, but now with the CRA, the same type of accountability is going to happen in embedded systems. CRA, what it wants or what should help manufacturers achieve is the protection of the brand, the users, and the business continuity. So turning the lessons we have learned for this type of attacks from these real-world incidents into something that could be applied to embedded systems. Implementing the CRA is not easy or might not be easy depending on the processes that you have in place at the moment, and is not free, takes time and effort and resources. And it's a huge shift if we think of it in embedded industries or companies working with embedded devices that have traditionally managed these two domains separately and shipping devices that actually have stayed in the field with minimal maintenance and minimal updates. With the CRA, organizations will need dedicated people to manage vulnerability disclosure, handle the incident reports, and maintain also non-commercial components that might be part of the bill of materials. The CRA requires specifically that manufacturers monitor, report, and address vulnerabilities in the products. So companies need to set up an internal process to do this and evaluate the impact of a potential threat, and then issue a patch or a mitigation update within a time frame. Vulnerability disclosure policies need to be public and accessible so that users can report issues as well and see what's happening with regarding security to the products. And again, for many organizations, this may require new infrastructure that needs to be put in place. Dedicated security response teams, escalation paths, integration with the EU authorities for incident reporting and other entities as well. And it needs to happen continuously. So it's a continuous responsibility. The supply chain in embedded devices tends to be complex. As you know, many products may have different components that then become one. So there is third-party software, open source components, for example, licensed modules that are all part of a final device. But under the CRA, manufacturers are accountable for security of everything that's inside the product, even if they didn't write it. So this means that when sourcing a component for your product, you need to vet a supplier, you need to be transparent with your software bill of materials to understand what's part of your product, and then perform verification on the dependencies. Make sure that those dependencies are secure. And for embedded systems, this could be a major challenge because of the amount of components that make up a device and the amount of suppliers which are operating globally, and then the life cycle of the device, which are long. So, for example, if you were to build your own crypto libraries or secure communication stack, it might take years depending on the complexity of the product. But then again, a vulnerability in a third-party library can become or will become your problem. So these are type of strategic decisions that the company needs to assess and decide which way they want to move forward. It can cause an impact in their strategy. CRA compliance depends heavily on evidence. I mentioned several times already that you will need to show to the authorities like EU that you have assessed the risks, you have mitigation process in place. If there is a patch that needs to be released, you have tested that, and overall that you can trace back to the product design and the requirements. And this process might sound familiar to people or to any one of you who has worked in functional safety already. The difference is now that in addition to the safety part, you must also document security decisions the same way you document safety ones. And one of the challenges for embedded devices or for embedded companies is that this is not necessarily just a technical issue, as we said, but it becomes company-wide responsibility, and it might require also a cultural shift that we consider security in everything we do. At least we have it in the back of our minds and keep thinking about secure processes and ways of doing or performing our tasks in a secure manner. Now a few words on functional safety. Functional safety, it's about predictable control behavior under all conditions. And compared to standard software development, it requires full traceability from requirements to testing, rigorous risk analysis and verification and every phase of the development process. And it's not faster nor cheap thing to do, but it ensures that every component in your device contributes to the overall system reliability. And if we apply this same mindset to cybersecurity, the result is a stronger and more trustworthy system overall. The functional safety is providing infrastructure for compliance. So if your organization is already developing according to any of the functional safety standards that apply to safety critical industries, you will already have documented processes in place, risk management frameworks, verification validation tools, change and configuration management, and overall traceability. And these are aspects that are also required for the security part, just apply to security instead of safety. So instead of reinventing the wheel, you can extend your safety management systems to think about cybersecurity as well. And this slide is where everything we have talked about before comes together. So we have looked at the CRA demands in terms of cybersecurity. And I just mentioned that functional safety has been addressing similar type of processes for years. And one of the key questions is how to design for both and at the same time. So if we think about this in terms of system integrity, which is the point where safety and security meet, we can ensure that the system will behave predictably and correctively, even when things go wrong, whether that's caused by a random failure in the case of functional safety or by a deliberate attack in the case of security. In practical terms, this means ensuring three things, at least from Tuxera's experience and from our perspective. So one of those three things, very important thing, is guaranteeing data integrity, no corruption, even under power loss or attack. The ability to provide deterministic completion of the processes and to control the access between software components and the data paths, and then the traceability, giving full visibility from design to deployment, what decisions have been taken, what type of changes, by whom, what are test results, and so on and so forth. And with this approach, you can ensure that data integrity and system resilience go hand in hand, because you can't really have one without the other any longer. And for us, when we say secure by design, what we mean is that security and safety principles are built into every layer of the technology stack that we are providing, from how we manage the data on the flash storage to how we handle communications across a network. With the current portfolio that we have, we cover both data at rest and data in transit. With flash management and file systems, we guarantee the data integrity, and with the networking stack and our encryption library, the secure communications from the device to device or device to cloud, for example. To store the data, we can combine our file systems with the encryption layer as well. And then on the communication side, we have secure networking protocols like MACsec, IPsec, TLS, all integrated as part of the stack. The idea is that we can provide or guarantee consistent data even in the event of an unexpected shutdown or attack. So you can rely on the data after the system has been brought back to life, as well as preventing the data corruption, which is one of the most dangerous and hardest to detect failure modes in embedded systems. But overall, end-to-end protection to meet both functional safety and security requirements. Few words about the business side, because being compliant and building secure and safe system is more than just checking these regulatory boxes. It can help you create a competitive advantage in the market. And when you embed security and safety practices in your stack, this can become a differentiator for your product. You can spend months, sometimes years, developing your own stacks or your own middleware to try and meet the safety and cybersecurity requirements, but that can become expensive, as well as risky and hard to maintain. What happens if somebody from your team leaves the company, or if there is a reshuffling in engineering, and that type of challenges can happen. So you need to consider whether to do it in-house or source from a provider that could take already a design or that has designed its products according to secure and safe practices and standards. That way you can also get faster time to market and spend less time reinventing the wheel and cut on integration and validation time. It can also help you reduce the exposure to risk of non-compliance, which as I mentioned before, in the case of CRA, can go from fines to even block your entry to the European market. A few words about where our products are deployed and where is our experience coming from. We are shipping in in thousands of mission-critical devices in industries where data failure or security flaw can have very, very serious consequences. So from smart meters to industrial robots, aircraft systems, connected vehicles. industrial PLCs, and many different type of devices. And the challenges might be or might look different on the surface across these industries, but the underlying need remains the same. You need data reliability, secure operation, and predictable performance across the full product life cycle. To give you some examples of the companies we work with, more than 3,000 companies are using these days our technology. You see here some global leaders in automotive, aerospace, industrial automation, smart energy. So again, companies that cannot afford unpredictable behavior or losing their data. We have helped these type of corporations integrating, certifying, and maintaining their systems across their industries. We usually have very long-term relationships with these customers, so we can provide long-term support, updates, vulnerability management across the whole life cycle, and ensure that the software evolves alongside their products as well. They can keep their focus on their own devices. In this slide, almost at the end of the presentation, but I just wanted to show an example of the impact of safety and cybersecurity in the real world. In this example, I'm representing an industrial automation environment where safety and cybersecurity are no longer separated, and a single software vulnerability or adapt corruption event can take your production line to a halt, or can even compromise the worker safety or impact the overall infrastructure of a factory, for example. In industrial automation, operational technology systems like devices, meaning the controllers and devices that are running on the factories, energy grids, meters, and then IT systems like cloud servers. Those type of environments are these days converging. So this convergence of IT, OT domain is meant to improve efficiency, but it also opens new challenges and new vulnerabilities. Traditionally, the OT aspect, the devices were in a way are isolated and static, and they run safely, but they were not necessarily designed to be connected to other systems. These days, already for the past years, with Industry 4.0, edge computing, remote monitoring, more and more the OT devices need to be part of the whole IT infrastructure. And again, that connectivity, that new link introduces a new possibility for attack, a new attack surface. A compromised controller or a compromised sensor input can propagate errors across an entire production line. And then you also have to consider that many of these devices have life cycles of many decades. So maintaining the cybersecurity or security practices on those is a huge challenge. So this is the exact the type of a scenario that the Cyber Resilience Act and other security regulations want to address. That the devices on the OT side remain secure, and that every connected component from hardware to software can resist or can handle vulnerabilities throughout the life cycle. And some of the questions that we get often from companies working on this domain are related to how to protect against cybersecurity incidents while protecting against power failures at the same time. How do we keep devices that are already in the field, so decades-old devices, compliant under the CRA? How should we handle updates safely without disrupting the production? So these are some type of questions that we can help customers with by guaranteeing safe and fast recovery from power losses and the data integrity, minimizing their downtime, but also with the vulnerability reporting and the secure processes that we have in place, as well as reducing certification time. But just to sum up, the industrial world is a good example to see that there is no safety without security. The idea is to make this integration now practical and ready for the future as well. Couple more slides to go. As discussed, the timeline for safe and secure products is already in motion, and companies that start working on this today will not only be compliant by next year, but they will also become more efficient and trusted and competitive in the market. And security will ensure that the safety mechanisms themselves can be trusted. So it goes beyond the cost of investing in safety. It will become in safety and security. It will become a differentiator. The advice, if there is possibility to give any advice, is to move towards a more proactive approach and start thinking of cybersecurity from the very beginning, from the requirements stage, so that it can be integrated into the whole product development life cycle. And again, this is something that will require a mindset change in many organizations, because historically, safety and quality and security have been their own domains and managed separately. But it's doable, and then you can also, of course, as I mentioned before, think of what type of components could be sourced from a third-party provider, what needs to be done in-house, and overall how to manage your supply chain to consider this. And to sum up, we have covered a lot today, but before we close, a couple of things. Security and safety go hand in hand. You can't anymore achieve one without the other, and both will start with leadership commitment and a clear strategy from the organization. And companies that act early will see their costs and complexity reduced later on, and will earn the trust of their customers and partners, so they can prove the quality and reliability of the devices. So it's good to start already thinking about this and ask yourself, like, are we designing securely by default? Do we have proper vulnerability management and patching in place? How do we ensure that safety mechanisms can remain trustworthy in the years ahead? To remember again that if you have already functional safety processes in place, you should have already some sort of framework that will help you for security and CRA. And yeah, basically just want to thank you for your time today. Remember that there is no safety without security. And if you would like to learn more about how Tuxera ourselves, how we can help you secure your systems, do reach out to us. We'll be happy to continue the discussion. Thank you very much.